Now that you know about NetFlow basics and the benefits that it can provide, let's talk about the different NetFlow versions. NetFlow version 1 was, well, the first version of NetFlow. It was only limited to IPv4 without network masks and autonomous system numbers. It is now obsolete. NetFlow version 5 is a very popular NetFlow version. It has fixed values of the different types of information that it can gather and place in the NetFlow record. For example, not only does it capture the 5-tuple information that we talked about, it can also gather information such as the IP type of service, the autonomous system number of the source or destination, as well as the source and destination masks. As you can probably infer, the more information that is included in the NetFlow record, the more analytics that can be performed during traffic analysis, which is why NetFlow version 5 was so popular. It allowed for more than just the 5-tuple information to be gathered. But what if you wanted even more information than that? Well, fortunately, there's NetFlow version 9. The great thing about NetFlow version 9 is that it is template-based. This means that network engineers can choose the data that they want to collect on rather than being restricted to a predefined set of fields. What is also convenient about using template-based NetFlow is that any additions to NetFlow do not require complete rewrites of software in order to support NetFlow version 9. So how does NetFlow version 9 work? The NetFlow packet header consists of at least one template that the receiving device should use. For our discussion, we will use Cisco StealthWatch as a receiving device. So StealthWatch will receive the first packet and see the template that it can expect all future NetFlow packets to follow. This way, StealthWatch can dynamically be updated in order to handle the type of information that the network security engineer wants a record of. While there isn't a mandatory port that NetFlow uses between the switch and the receiving device, in this case StealthWatch, commonly UDP port 2055 is used. However, ports like 9025, 9026, 9555, and 9995 can also be used. Not only does NetFlow version 9 allow for completely customizable flow sets, it also allows for even more information to be captured. Specifically, NetFlow version 9 has 127 different field types, and NetFlow version 9 has support for IPv6, which wasn't available in the previous versions. Now, you can record information such as MPLS information, VLAN information, source and destination MAC addresses, and even the application of the traffic. As you can imagine, the more information that is captured, the better analytics can be, which means more accurate baselines, which means any anomalies of the types of traffic can be seen. This allows for not only a quicker security response, but also better information to engineer networks or to troubleshoot with. And I also wanted to tell you about flexible NetFlow. Flexible NetFlow allows the information gathered by NetFlow to be stored in various cache buckets. Earlier in the module, I told you that NetFlow records are stored in a database referred to as the NetFlow cache. For regular NetFlow, this cache holds all the NetFlow information. Flexible NetFlow allows for different caches to hold different types of information. So if desired, these caches can then be sent to various flow monitoring tools, each with a designated purpose. For example, there could be a separate cache for security flow information, as well as another cache for multicast flow information. Then, flow records from each cache could be sent to the respective StealthWatch applications. Flexible NetFlow also allows for more granular information to be collected. Now, specific information about the transport layer, such as TCP acknowledgement number, window size, and ICMP code and type, can be captured. Additionally, Flexible NetFlow allows for users to define the type of information they want to have captured in a Flexible NetFlow record. Like I mentioned earlier in the module, NetFlow was created by Cisco, and, like a lot of other technologies that Cisco has developed, the IETF wanted to create a standard so any vendor could use the benefits of Flow. IPFix is that standard, and it stands for Internet Protocol Flow Information Export. IPFix used NetFlow version 9 as its basis of design. So that means IPFix also supports templates. Again, this allows the administrator to determine which information is captured by IPFix and then to forward it on to be analyzed. The default port for IPFix is UDP port 4739, but it also supports SCTP as well as TCP. So how do you configure Flexible NetFlow? First, you need to configure the flow record. The flow record will determine what information in the traffic will be collected. You can either define your own record or use pre-existing records. Then, you need to create a flow exporter. This will determine where the NetFlow records will be sent to. After that, you need to create a flow monitor. This monitor is a container that holds the flow record that was created, as well as the flow exporter. Finally, the last step is to apply the flow monitor to each interface that you want NetFlow to be generated on. Cisco recommends that if you are capturing every interface, which you should, to apply the flow monitor in the ingress direction.